Hi everyone and welcome to the channel. Today I'm excited to introduce you to the latest AI Accelerator from Team Synapsewerx. This accelerator has its heritage in the Boomi 2024 hackathon, where our recommendation engine was announced as one of the winning solutions. Since then, it's been refined, improved and packaged as a solution to help you accelerate its implementation within your organization using your proprietary loyalty customer data and placements that are specific to your products, services, and vendor partnerships. The Synapsewerx recommendation engine is perfect for any scenario where you want relevant product placement at the exact time of customer decision making. So, for example, this could be a loyalty customer that's walking into your store, or as they're browsing products online and adding those products to a shopping cart. It could be as they are browsing for their next online educational course, or as they are using your digitally enabled shopping cart, walking up the aisle and are looking to add a product to the trolley. Placing products that resonate with the interests of the customer at the time of purchase can be beneficial to you, to your customers, and your vendor partners. And the Synapsewerx recommendation engine is designed to maximize the match between a customer's specific interests and the products available in your store. Now, today, the Synapsewerx engineers behind the solution are going to provide you with a detailed walkthrough of the solution architecture. They will show you how the AI agent can be implemented within an enterprise application landscape and give you a demonstration of the secure, containerized AI agent that's at the core of this accelerator. Now, get ready to hear from the Synapsewerx team, who are going to take you on a journey through the solution. Enjoy.
Now, let's dive deeper into how this works in reality and explore how Boomi enables us to gather high-quality data in near real time while building a state-of-the-art AI agent choreography. At Synapsewerx, we strongly believe that the first step in exploring AI is to ensure that data quality is consistently high and maintained up-to-date for near real-time business operations. Achieving this requires a robust mechanism to automatically synchronize, deduplicate, and enrich golden records across backend systems. Boomi enables this by seamlessly extending traditional integration efforts with an always up-to-date data hub. This near real-time synchronization guarantees that data remains accurate, consistent, and allows near real-time intelligent decisions. As illustrated in this diagram, Boomi DataHub is central to our AI agent reference architecture, serving as the backbone for seamless data integration and AI-driven decision-making. To demonstrate the capabilities of our intelligent recommendation engine, we will explore a use case centered on targeted marketing campaigns. For this example, Salesforce will serve as the primary source system, incorporating Marketing Cloud, Sales Cloud, and Loyalty Cloud management to provide a comprehensive view of customer engagement. Each data module holds essential details on paid campaigns, advertisers, ad content, and their alignment with enrolled end users based on interests, budgets, aspirations, and more. This data is automatically sourced from Salesforce into Boomi DataHub, where it is synchronized, deduplicated, and enriched into golden records, making it ready for use by our AI agent-driven campaign engine. While this example uses Salesforce as the source, the architecture is flexible and remains unchanged across other potential use cases and backend systems such as SAP, ServiceNow, or traditional databases. Once we have established highly optimized and always up-to-date golden records, the next step is to implement an AI context pipeline. Let's dive into it. This pipeline, built in Boomi, is part of the accelerator and aims to continuously ingest changes from DataHub, utilizing a selected embedding model to tokenize all this information. Once the golden records are converted into embeddings, they are stored in a vector database of choice. In this case, we are using AstraDB, selected for its high performance, scalability, and resilience. So far, we have ensured that any changes in our backend systems, Salesforce in this use case, are seamlessly converted into embeddings tokens and pushed into the AstraDB vector database, making the data available for AI-driven decision-making. Now, let's move into the main chain of orchestration. This component is also built in Boomi and forms part of this overall accelerator as well, where our recommendation engine is triggered and set into motion. Let's break it down step by step. As part of the AI action pipeline, and for the purpose of this use case, an end user who is already enrolled in a loyalty program signs in through an engagement channel. This could be a website, a mobile application, or a more advanced digital touchpoint. Once the subject identity has been confirmed through a standard authentication process, the next step is to propagate that identity and trigger the AI recommendation engine. Let's zoom into it. As mentioned earlier, the recommendation engine leverages the user's credentials to access the vector database and perform multiple cosine similarity search. This search is conducted against a set of continuously updated embeddings maintained through the AI Context Pipeline that we previously described. The objective is to identify the most relevant product advertisement that aligns with the user's individual interests and preferences. When a high probability match is found, the recommended advertisement is returned to the main AI chain process for execution and delivery. In the next sections of this video, we will dive deeper into how this works under the hood. For now, let's zoom back into the main AI chain. Coming back to the main AI chain process, we have generated an event object that encapsulates all the necessary details of the ad recommendation tailored to that specific user. From this point forward, how we choose to use the recommendation output is entirely up to us. For instance, let's assume the recommendation engine is set to generate a targeted advertisement video to be displayed on the user's screen. Let's take a quick look at how this could be orchestrated from here. Depending on the requirement for responsiveness, we may choose to publish this event into a Kafka topic. This approach ensures real-time delivery and consumption by any downstream system or services that need to act on the recommendation. This allows the event consumer to operate as a continuous subscriber to the Kafka topic, so that as soon as new events is published, the process immediately consumes it and, as its first step, plays the recommended video in front of the end user's screen in real time. From here, additional AI agents could be introduced to track end user engagement and behavioral signals. However, that falls outside the scope of this demonstration. In a nutshell, this is what we will be demonstrating in the upcoming sections of this video. We will begin by showcasing the Boomi components, followed by a deep dive into the intelligent and versatile recommendation engine.
So now that we have seen the solution architecture of the entire AI idea, we'll see what is powering the solution under the hood. So what you see in the screen is the Salesforce instance that we have created for the solution, and we have created contacts in Salesforce. So each contact will have the name of the user, and you can see there are also objects called interest. So these objects hold the user's interest in pure natural language. So here you can see the user Sreeraj is interested in beverages category, and he has put in a lot of textual description of what he is interested in. And we have something called as accounts, which equates to a vendor in Salesforce. So you can see there are a lot of accounts that you have created, and when you go inside an account, you can see each account has got products. So the products gives us details about each products, which category it belongs to, and the competitors for the products. And we have something called as campaigns for marketing. When you go to campaigns, you can see there are different campaigns. Here, when we select one of the campaign called Black Friday EV sale, it is for the product Model 3. It has got the campaign name and the target prospect markets to target this campaign. Then we have a start date and end date. So each campaign has got a related display against it, which will give an idea of where the ad has to run. So here you can see this particular campaign has to run in the High Point Shopping Mall in the L2 entrance lobby, and this is for the Black Friday EV sale. And for the Salesforce act as a primary source of data, but for the source of truth, we use Boomi as our single source of truth for all the data. And here you can see we have created an MDH in Boomi, which has 3 different models, one for users, one for engagement, and one for advertisement. The users instance has 2 sources. One is Salesforce, which picks up different objects from Salesforce or different attributes of the user from Salesforce, and there is an AI agent which is accepting the channel updates. Same way for other models. Now we go back to AstraDB, which is our vector database for storing all the information related to the AI embeddings. So once the user data or everything is received from Salesforce and added to the MDH, Boomi will capture all the information and they get converted to embeddings and will be stored in the database that you have created in AstraDB as a vector. So only detail that is available for user will be the user ID, and no other personal information is stored in the AstraDB, but everything will be stored in the vectorized format, which can be directly used by the AI agent to find the similarity mappings. Now let's see how Boomi helps in connecting all those things together. So as I said, there are multiple processes in Boomi that we have created to sync data between Salesforce, other data sources and MDH, as well as the AstraDB. So here we can see there are different processes that we have created. If we go inside the DataHub, there are 3 processes here. One is Salesforce advertisement process, Salesforce to MDH products process, and Salesforce user info to MDH process. So each process is responsible for getting the updates from Salesforce and sending it to the master data hub. And once the master data hub is updated with the golden record, a channel update is sent back to Boomi, and these processes which are created are responsible for sending the channel updates to the AstraDB. So here you can see there is an MDH user detail to vector DB process. So once a user detail is updated or created in the MDH, this process gets triggered, and what happens is it sends the user details to OpenAI to create the embeddings of the user data, and then it gets sent to the AstraDB to store the vector details of the database, which can be directly used by the AI agent. Now what happens is when an advertisement info, for that I'll just show the data that we have. So here you can see each repository in the golden in the MDH has got all the data that we need. The engagement data model, the users data model has all the user details, the user's card number, loyalty card number, user ID, record title, and everything. It will also have the user's interests captured from Salesforce. So this is how Boomi will chain all the AI related sources and systems together to make this solution possible. Thank you.
Let's begin with a quick overview of what a recommendation engine does. At its core, a recommendation engine is an intelligent system that analyzes patterns, preferences, and behaviors to suggest items that are most relevant to an individual. Whether it is recommending a book to an end user, an enrollment subject to a student, or in this case, a product to an enrolled loyalty user, its purpose is to reduce information overload and help the user discover what matters most to them in the moment that it counts. Now let us consider how this translates into a marketing context. As it has already been described, in this particular demo, an organization wishes to run a targeted marketing campaign using personalized product recommendations. Each loyalty program enrolled customer has a unique profile made up of their stated interests, past interactions, and behavioral signals. On the other side, there is a catalog of available products, each tagged with descriptors, features, and advertising metadata. The challenge is to intelligently match each customer with the product they are most likely to find engaging, and to do so in a fast, scalable, and accurate manner. This is where our AI-based intelligent recommendation engine comes into play. The architecture works as follows. The engine is fully containerized using Docker, allowing for portability and seamless deployment. When the user logs in or interacts with the system, the backend receives their unique customer ID. This ID is then used to connect to a secure database, in this case, AstraDB, a distributed cloud-native database optimized for handling high-speed recommendation queries. As previously described, with Boomi, we are continuously operating an AI Context Pipeline designed to transform golden records from Boomi DataHub into semantic embeddings. These embeddings are then securely stored in AstraDB, a vector database optimized for high-performance similarity searches. Within AstraDB, there is a dedicated collection that captures customer interests in embedding format, enabling intelligent and scalable matching across marketing and product recommendation workflows. On the other hand, each customer ID may have multiple associated interests. These could be categories like fitness technology, eco-friendly homeware, or smart travel accessories. For every individual interest linked to that customer, the system performs a similarity search against a second collection called the advertisements collection. This collection holds all the available product entries that are part of the campaign, each with its own metadata such as key features, purpose, and target audience descriptors. Using cosine similarity, a well-known metric in vector space modeling, the engine compares each customer interest with a full set of products. Cosine similarity measures how closely two vectors align in multidimensional space. In simple terms, the higher the similarity score, the more closely matched the product is to the customer's interests. The engine loops through each interest, runs a similarity search, and collects the top results for each pass. Once all interests have been processed, the system identifies a product with the highest overall similarity score across all customer interests. This becomes the final recommendation. The selected product is then retrieved along with the associated video URL or promotional link and returned to the front-end experience, as we can see in this demo. Let's start with AstraDB. Here we have our AstraDB database, and it contains two collections, the user interests collection and the advertisements collection. The user interests collection contains information about each customer's specific interests. In our demo, we're going to assume we're receiving customer ID as follows. Now, this is de-identified information, so we don't know who this customer actually is. But what I can do is I can check to see how many interests this particular customer has. And as we can see from the table below, this customer has interests in beverages, movies, groceries, cars, hobbies, travel, and technology. If we look inside the advertisements collections, where our advertisers are paying to promote their products, we have L'Oreal Paris, an airport destination, a Bravia TV, a Model 3 Tesla car, Omo sensitive washing powder, and Sony headphones. Now that we've had a look inside AstraDB, let's go and have a look at the code running in VS Code. Here's VS Code, and here's the Python code version 7.1 in this window here. This is essentially the recommendation engine. It takes in a customer customer ID, calls AstraDB, finds the user interests for that customer ID, does a similarity search against the advertisements collection to find the most appropriate product for each user interest. Without going through every single line of code, let's just run it and see. I'll talk you through how it's processing the information. The first thing to do is to run the Docker image. So the code's now waiting for an instruction. In the terminal window on the right hand side, I can call the Docker container and request the top URL for customer ID that we just plugged into AstraDB there. So there's the customer ID right there, ending in QAG. I'm sending a recommend request for the top URL for that customer ID. Let's hit return. And what we'll see is the processing will happen in the left-hand terminal window. So we have a recommended URL of the product with the highest similarity score across all those user interests. Let's just take a look at the output from the code. And remember that we had 7 interests for this particular customer ID. And so let's just remind ourselves what those interests are. Groceries, movies, technology, travel, beverages, cars, hobbies. Okay, looping through each one of those 7 user interests. First one being beverages. Well, we don't actually have any beverages in our advertisements collection. The closest to beverages it's come up with is the Omo sensitive washing powder with a score of 0.69. The next interest is for movies. And so, again, we don't have any specific movies in the advertisements collection, but it's come up with the Sony headphones as being the most appropriate score product for that particular user's interest based upon the user interest descriptions. The next one is ethnic foods and gourmet ingredients under groceries. Again, we don't really have any specific products directly matching that, but again, Omo sensitive has come up there as a consumer product. Next one is cars. The description is SUVs and family vehicles. It's come up with the Model 3 as the highest score for this user interest, being a car. Fair enough. 0.77, that's our highest similarity search score yet. Let's move on to the next interest, which is hobbies, cooking and baking. No real products matching that, but again, the Sony headphones coming in with a score of 0.72578,263. The next user interest is travel, description being beach, vacations and relaxation. Here it's come up with Changi Airport, although not really a beach destination, it's obviously related to travel. So the similarity search score there is 0.722. And finally, we have technology with a description of audio equipment and home theater. Here we see the Bravia TV score, similarity search score of 0.778. And that has slightly beaten the similarity search score of the Model 3 against the user's interest in cars. So if we scroll down to the end of the output, it's indeed saying that the Bravia TV, which is a cinematic TV, is producing the highest similarity search score of 0.778, and it returns the URL for that video of that product, which I'm now going to play. So you get the gist of how the similarity search score recommendation engine works. The Bravia TV being a home cinema television, makes sense that that's come back with a slightly higher score compared to the user's interest in cars, where we had the Model 3. But if we recall, if we go back to Astra and the user interests, we can see that the user's interest in cars was really for SUVs and family vehicles. And the Model 3, if the Model 3 was an SUV, then I could understand why that might be a better fit. But it's the Sony Bravia TV that takes the winning recommendation, because the user's interest in technology is for audio equipment and home theatre. There we go. That's the customer recommendation engine from Synapsewerx. Thank you very much for listening, and I hope you've enjoyed this demonstration of the AI Accelerator.
My thanks to Carlos, Sreeraj and Chris for walking us through the features and functionality of the recommendation engine. You've just seen how the Synapsewerx recommendation engine leverages Boomi to identify and engage with customers at the exact time they are most likely to make a purchasing decision. The same technology can be used to guide students studying at a TAFE or a university along a learning pathway, or the same agents and recommendation engine can help sales teams prioritize and triage prospective customers in a car sales showroom. The use cases for the Synapsewerx recommendation engine are vast, and with our help can be quick to tune and implement within your enterprise workflow. Now, I hope everyone that's still watching today's walkthrough has got something of value out of it. If you want to know more about the presenters, the solution that's been demonstrated today, or you just want to learn some more about integration and AI, then please check out the description below, where you'll find all the links that you need. Finally, before we finish the session, I'd like to thank you for spending this time with us today. If you've liked what you've seen and heard, then please do us a favor and hit the like and subscribe buttons below. If you've got any questions for anyone in the chat today, then drop your questions and views in the comments below. Thanks again, and until next time, keep having fun with meaningful technology. Thank you.